ठीक है सर. Hello everyone, I am Vipin Kumar and I welcome you all to Accent Gate Academy 2.0. So, today we are going to continue our discussion on heat and mass transfer, and we are going ahead with today's topic as fins and unsteady state conduction. Okay, तो conduction हम पहले देख चुके हैं, right? Conduction we have solved almost 40 questions, I think maybe more than that. Okay, just give me 1 second. Okay, now let's move ahead. So I know that you can see the question on the screen, the first question, and it is from, so it is a, today's session will be a combination of fins as well as unsteady state heat conduction, and I hope that you have already done your revision, the formulas and the concept of these two topics. So let us start with the first question. Okay, I hope that you can see that on the screen. Just give me 1 second, let me sort this out. Okay, so yeah, let's start. First question, I know that you can see that on the screen. Hello. तो सर एक बार आप ये स्ट्रीमिंग दोबारा हम स्टार्ट करेंगे आप? Okay. Hi everyone, we are back again. So there was a short, delay. There was short, little bit of issue, technical issue in the settings. Anyway, we have figured it out. Let's start the session. We are starting like 11 minutes late, so we'll continue maybe 10-15 minutes later the session till 6:45 probably. Anyway, so Today, what we are going to do, we are going to focus on the questions based on fins and unsteady state. I hope, yeah, so it's audible as well as you can see what I'm writing. Okay, these are the two topics that we are going to cover and get PYQs. Okay, very well. Let us start. Let us move forward with the first question. Question number one. Let's take 20 seconds to read out the question very quickly and then we will move ahead with the solution. Okay. So, okay. Let's try to read the question together. What do we have? We have a steel ball of diameter 12 millimeter is heated to 1225 Kelvin. Okay. So the initial temperature is 1225 Kelvin. It is then slowly cooled in air to a temperature of 475. So the final temperature or an intermediate temperature T is 475 Kelvin. Now during the cooling process, the ambient temperature is 325. So the ambient means T infinite. Okay. Free steam temperature is 325 Kelvin, right? And the heat transfer coefficient is also given. H is equals to 30 watt per meter square Kelvin. Some physical properties of steel is also given. What? Density of steel is equals to 7800 kg per meter cube is given. And the specific heat is 600 joule per kg Kelvin. Now they are already telling us that use lumped heat capacity analysis. That means we do not have to verify Biot number or anything. Directly we can use lumped heat analysis. What is lumped heat analysis? Lumped heat capacity analysis is only valid when Biot number is less than 0.1. So usually you need to check if you can apply lumped heat capacity analysis. But in this particular question, they have directly given you that using the lumped capacity method. So when Biot number is already less than 0.1, we already know this. Okay. The calculated time period for the required cooling. That means the time that is required for this steel ball to go from initial temperature to this intermediate temperature, I need to find out what is the time that is required. What is the time that is required? Now, according to lump heat capacity analysis, I hope that you are all aware of this derivation that we have done. T minus T infinite upon T initial minus T infinite is equals to e to the power minus HA by rho VC into time, right? And what is this thing called? This is called as time constant tau. Tau is equals to rho VC by HA. Okay. So they have given more or less everything to us. We just have to calculate this time. You see, they have given us, first of all, you need to calculate V by area, volume per unit area. Okay, this is also called as characteristic length, and we have defined it many times. It is d by 6, diameter by 6. Volume 4 by 3 pi r cube divided by 4 pi r square, which is the area. And you will be able to find out LC is equals to d by 6. Okay. So let us try to put the values. Intermediate temperature 475 minus 1225 by T infinite. I'm sorry, just 1 second. This is 375 minus 325 T initial 1225 minus 325 is equals to e to the power minus h की वैल्यू कितनी है 30 है अपॉन रो डेंसिटी कितनी है 7800 है सी स्पेसिफिक हीट कितनी है 600 है and V by A is D by 6. So you see V by A, this V by A I can write D by 6. तो diameter कितना है 12 into 10 to the power minus 3 by 6. Okay, so this is my equation multiplied by time. I need to find out this time. Simple. Okay, I hope it is. There is nothing in this. Okay, so if you solve this, although I have not solved it, it's 475 minus 325. It's 0.1667 is equals to e to the power minus t. This tau value, rho Vc by Ha, this tau value you will get 312 seconds. Tau is 312 seconds. So I need to write 312 here and time. This is minus here. Okay. No. This plus. Okay. Now you can take ln this side. Ln 0.1667 is equals to minus t by 312 and you calculate your time and time will be equal to 559.02 seconds. So this is the time that will be taken by the steel ball. Okay, so the initial temperature is Ti. From 1225 Kelvin to reach to 475 Kelvin, it will take around 560 seconds. Okay, so from Ti to intermediate temperature T, it will take 560 seconds. Okay, I hope this is clear, right? Good. So let's move ahead. Now I hope you can see the next question, right? Okay, so you can see the next question, right? Let's try to give it a read in 20 seconds and then we will try to solve this question. Very simple question. If you read the language, almost same. Only the variable that you need to find is different. Same concept, same formula. Only the variable that you need to find is different. Earlier we were calculating T time. This time we are calculating H heat transfer coefficient. Okay. So again, what do we have? We have a small metal bead. This time radius is given. Radius is equals to 0.5 millimeter. Okay. Initially means Ti is equals to 100 degrees Celsius. Now it is placed in a fluid with T infinite is equals to 20 degrees Celsius attains a temperature of 28 degrees Celsius. That means intermediate temperature is 28 डिग्री सेल्सियस इन हाउ मच टाइम टाइम इज ऑल्सो गिवन कितना टाइम लग रहा है टी इनिशियल से इंटरमीडिएट टेम्परेचर पे जाने के लिए इट्स टेक टाइम टेकन एज 4.35 seconds 4.35 seconds okay now the density is given for the metal bead density is equals to 8500 kg per meter cube and the specific heat is equals to 400 joule per kg Kelvin. Again, they are giving you that you can consider this as a lumped capacitance analysis. That means again you do not have to check the Biot number. Usually if they do not give you that you can use lumped capacity, then you need to check the Biot number. If it is less than 0.1, then only you can use the lumped capacity analysis. But in this case again they have given you that use lumped capacity analysis. Okay, calculate the convective heat transfer coefficient. Same concept, same formula, only the variable that needed to be that you need to calculate is different. Okay, so let's write lumped capacity analysis or lumped capacitance method, whatever you can call it. Right. So just now we have seen T minus T infinite upon T initial minus T infinite e to the power minus HA rho Vc into time. Everything is given to you. What is the intermediate temperature? 28. In T infinite is 100. T initial is, I'm sorry, T infinite is 20. It is 20. T initial is 100. This is 20. E to the power minus H I need to find out. Rho. Density is given 8500. C is given 400. And V by A, LC is equals to V by A is equals to D by 6 or R by 3. So R is also given. How much is R? 0.5 into 10 to the power minus 3 into 3 into time. How much is time? What is the time that is taking? 4.35. So everything is known, only H needed to be calculated. Okay. So this is what? 28 minus 28, 100 minus 20, 80. You can take this E on the other side as ln minus H into 3, 8500 into 400 into 0.5 into 10 to the power minus 3 into 4.35. So everything, it's very easy to solve. Nothing is there. Okay. ln 8 by 80. You can calculate this and you will get H. Okay. So H you will get 299.8 watt per meter square Kelvin. Okay. Very easy. Unsteady questions, mostly this concept is going to be applied. Okay. There is no other, there is one more concept we are going to see, but 99% only this much concept is more than enough. Okay. Chalo. Let us see the next question. Okay. I hope that is visible to you. Okay. Question. What it is saying? Again, a metal ball of diameter is given, diameter is 60 millimeter, is initially at 220 degrees Celsius. The ball is suddenly cooled by an air jet of 20 degrees Celsius. That means T infinite is equals to 20 degrees Celsius. Heat transfer coefficient is given how much? 200 watt per meter square Kelvin is given. Okay, H is also given. Has it not changed? Okay, I think the window is not changing. Just let me check one more time. Just wait. Okay. So I hope you are able to see the question. Let us move forward. By specific heat is given, right? Let me just verify if the question is shown on the screen. Yeah, it is visible. Okay. So the question is telling you that again we have a metal ball of diameter 60 millimeter and it is initially at 220 degrees Celsius. The ball is suddenly cooled by an air jet of temperature 20 degrees Celsius. Okay, so the air jet, the surrounding temperature around the ball is basically 20 degree Celsius, right? Then the heat transfer coefficient is given 200 watt per meter square Kelvin. Specific heat is given Cp is equals to 400 joule per kg Kelvin. Thermal conductivity is also given K is equals to 400 watt per meter Kelvin and 9000 density is equals to 9000 kg per meter cube respectively. Boil temperature after 90 seconds, that means T is equals to 90 seconds. I need to find out after 90 seconds what will be the temperature of the fluid. What will be the temperature of fluid? So again I can use the same concept. Okay, so using lumped capacity analysis, what can I write? T minus T infinite upon T initial minus T infinite E minus HA rho VC by I, right? Again LC is equals to volume by area is equals to D by 6. Okay, now I need to find out this temperature. T infinite is 20, T initial is 220 minus T infinite is 20. Okay, इज इक्वल्स टू ई टू द पावर एच कितना दिया है 200, डेंसिटी कितना दिया है 9000, सी कितना दिया है 400 एंड वी बाई ए इज 60 इंटू 10 टू द पावर -3 बाई 6। ओके, और कितने टाइम में 90 सेकेंड्स, 90 सेकेंड्स। ओके, so it's very easy, you can solve this, right? So this is t minus 20, t is equals to 20 plus 200 into e to the power. If you can solve this, you will get, yeah, you will get minus 90 by 180. Okay, so very simple now. You can solve this. T is equals to, you will get 141.3 degree Celsius. That means the answer is A. Answer is A. Right? Chalo. Let's move on to the next question. Okay, okay. So I hope that is visible. Let us take 20 seconds to read out the question and then we will start with the solution. Okay. Okay. Now what is the question saying? A long, slender metallic rod of length L is used as a fin. As shown in figure, so it is a finite length fin. Okay. As shown in the figure, the left end of the fin is kept at in a constant temperature. That means the base is maintained at a constant temperature, and the fin loses heat by convection to the atmosphere, which is at the temperature Ta. So the atmosphere that is there is at temperature Ta here. Four options are given. Options of temperature profile are given. Identify the correct option. You have to identify the correct option. Okay, so we have to see that how the temperature profile will vary with respect to x. Will vary with respect to x. Okay, so before we do that, we need to understand first of all what is. First of all, you need to know one thing. Look, this is a fin. So the case fin with finite length. We are going to use finite length. And tell me what was the temperature distribution for the fin with finite length? It was theta by theta naught, theta by theta naught, cos hm L minus x upon cos hm, right? This was the equation that we have solved during a derivation. Okay. Now we need to find out how what is theta? Theta is equals to T minus T infinite. Theta naught is T naught minus T infinite. Here T infinite is Ta, atmospheric temperature. So we need to find out how the theta is varying with x. How the theta is varying with, that is the main aim. Okay. So we are going to differentiate it twice. First of all, let us differentiate it once. Okay, so what we will get, 1 upon theta naught d theta by dx is equals to 1 upon, ये तो कांस्टेंट दिया तो बाहर आ जाएगा, d by dx cos hm l minus x. ओके, सो अगर हम इसे डिफ्रेंशिएट करेंगे, इफ वी डिफ्रेंशिएट इट विल गेट 1 अपॉन cos HML. इसका डिफरेंशिएशन क्या होगा, इसका डिफरेंशिएशन होगा माइनस एम साइन एच एम एल माइनस एक्स, राइट, माइनस एम होगा ना, एल माइनस एक्स का एक माइनस वन हमारे पास आएगा, ठीक है. So this is what you get. Now we have to differentiate it one more time. Okay, so when you differentiate it one more time, you can write this as 1 upon theta naught is equals to d square theta by dx square 1 upon cos hml d by dx का हमें इसका करना है, ठीक है. माइनस एम हम बाहर ले लेते हैं, लेट्स टेक माइनस एम एज आउटसाइड. ओके, तो यहां पे हमें मिल गया माइनस एम, क्योंकि ये कांस्टेंट है, राइट. तो यहां पे क्या हुआ हमारे पास, साइन एच एम एल माइनस एक्स, राइट. तो अगर हम इसे डिफ्रेंशिएट करेंगे एक बार और, तो क्या मिलेगा हमें, यू विल गेट माइनस एम अपॉन कॉस एच एम एल, ये तो बाहर वाला ही है, ये आ जाएगा माइनस एम कॉस एच एम एल माइनस एक्स. ओके, तो माइनस एम जो है यहां पे क्या आएगा, तो हमारा डी स्क्वायर थीटा, थीटा नॉट यहां आ गया, और ये आ जाएगा एम स्क्वायर कॉस एच एम एल माइनस एक्स अपॉन cos h ml. Okay, now if x is positive, x is increasing in positive x direction, then I can say that d square theta by dx square will be greater than 0. That means the slope will be positive, slope of tangent. So if I can say that d square theta by dx square is greater than 0, that means the slope of tangent with temperature distribution curve is positive. तो जब ये पॉजिटिव होता है तो कैसा ग्राफ बनता है, यू सी कॉनकेव अप. अगर आपका ये पॉजिटिव है, इफ डी स्क्वायर थीटा बाई डी एक्स स्क्वायर अगर ये पॉजिटिव होता है, तो ग्राफ आपका बनता है ऐसा, कॉनकेव अप, समथिंग लाइक दिस. ओके, सो दिस इज योर, इसे कहते हैं हम कॉनकेव अप. और अगर ये होता है नेगेटिव, डी स्क्वायर थीटा बाई डी एक्स स्क्वायर इज लेस देन 0, तो ये बनता है कॉनकेव डाउन, लाइक दिस. ओके, सो नाउ दिस इज कॉनकेव डाउन. Okay, so let's see the options. A cannot be true because A slope is 0. Okay, so B we can see it is concave up, C is concave down. So our option B is correct. Option B is correct. Okay. So option B is correct. Okay. Let's move on. Let's move on to the next question. Okay. I hope this question is visible to you. Slightly different concept we are going to use here. Okay. Now, let's try to read the question and then try to understand what if we can apply our unsteady state equations here or not. Okay. The question is saying we have two cylindrical rods A and B at the same initial temperature and simultaneously placed in a furnace. Okay. So उनका initial temperature same था. So can I write T initial of A is equals to T initial of B? Yes. Then are simultaneously placed in a furnace. That means if you are putting them in the same furnace, so T infinite of A and B will also be equal. The surface of the shaft remain at the furnace gas temperature at all times. Okay. So T is also intermediate temperature T is also equal to TB. The temperature variation in the axial direction of the shaft can be assumed to be negligible. So they are not happening in the axial direction, they are only happening in the radial direction. Okay. The data related to shaft A and B is given, diameter, thermal conductivity, and volumetric heat capacity is given. The temperature at the center line of the shaft A reaches 400 after 2 hours. That means T A is equals to 400 after 2 hours. 2 घंटे के बाद वो 400 डिग्री सेल्सियस से मिल जाता है. The time required for the center line of shaft B. So basically हमें बताना है कि जब TB 400 डिग्री सेल्सियस पहुंच जाएगा, so what will be the time? T we need to find out. TB we need to find out. Now look, here a different concept you are going to apply. So you see, lumped heat capacity analysis, we make some assumptions. We assumed that our conductive resistance is very less than the convective resistance. Okay, so there is no temperature variation inside the solid body. Okay, the temperature is uniform. But again, lumped heat capacity analysis came after few assumptions. Okay, but if you do not assume the assumptions that we take are for simplifications, but if we do not assume those things, the analysis will be very complicated. Now since the analysis is complicated, someone, I don't remember the name, but they gave a solution of those conditions with the error function. You can solve, you can calculate the time and the temperature, but with some error. Okay, so this is called an error function. Okay, and what they give, they basically give that you can calculate the temp. What is lumped heat capacity analysis? Lumped heat capacity analysis gives us that theta by theta naught, which is also equal to T minus T infinite upon Ti minus T infinite, equals to e to the power minus Ha rho Vc into tau. Okay, this is one analysis that we do, but there is a error function analysis also. Error function. This also gives us the same thing, but with a error function of z. Error function of z. Now you see here that since if I talk about this variable, this is what T minus T infinite upon T initial minus T infinite error function for ZA, right? And also if I write t minus t infinite upon t initial minus t infinite is equals to error function zb. Why? Because this t is same for a and b, t infinite is same, and t initial is also same. You see three conditions. So that means I can write that error function or za is equals to zb. Z is equals to zb. Now what is z? Z is equals to Ra upon 2 thermal diffusivity A into time of A. Okay, this is Rb 2 B into time B. Clear? Now this 2 and 2 can be cancelled. Okay, so let me take it to the other page. Ra under root alpha A time of A is equals to Rb under root alpha B time of B. Now what is alpha? Thermal diffusivity K upon rho Cp, right? You can calculate what is K. Thermal conductivity shaft A40, and this is 2 into 10 to the power 6. Rho B K upon rho Cp is 20 upon 1, no, 2 into 10 to the power 7. Okay, so you can calculate these things. Rho A, alpha A and alpha B. Alpha A is equals to 20 by 10 to the power 6 meter square per second, and this is 1 upon 10 to the power 6 meter square per second. Ra and Rb is also given, so I need to calculate Tb. So Tb will be equal to Rb by Ra whole square into alpha A by alpha B into Ta. Right? Simple. Now we know all the values. We know the diameter of A and B. So radius is very easy to find. Okay. So I can write कितना है ये? Diameter कितना है? 0.1, right? 0.1, क्योंकि ये कैंसिल हो जाएगा by 2. It is in ratio. So ratio of diameter or radius will remain same. आर कितना है? 0.4 स्क्वायर. ये कितना है? 20 into 10 to the power 6, 1 upon 10 to the power 6, and time कितना दिया हुआ है हमें? Time is 2 hours. So if I put this in hours, I will get TB also in hours. So TB you will get 2.5 hours. Okay, because they are giving in hours. So hours I have calculated. Okay, I hope it is clear. Now let us move on to the next question. Okay, a steel ball of 10 millimeter dia. तो डाया कितना है? 10 millimeter is at, यानी कि इनिशियल टेम्परेचर है आपका 1000 Kelvin, right? And it is required to be cooled at 350 Kelvin. तो आपका फाइनल टेम्परेचर क्या चाहिए आपको? 350 Kelvin. ओके, बाय इमर्सिंग इट इनटू अ वाटर ऑफ एनवायरमेंट, सो आपका जो फ्री स्टीम टेम्परेचर है वो है 300 Kelvin. Convective heat transfer coefficient is given how much? 1000 watt per meter square Kelvin. Thermal conductivity is also given 40 watt per meter Kelvin. Time constant is equals to 16 seconds and actual time I need to find out. Okay, so मैंने क्या बताया आपको, क्या इक्वेशन है, t minus t infinite upon t initial minus t infinite is equals to minus ha by rho vc into time. अब ये क्या होता है, दिस इज योर टाउ. ओके, तो आई कैन ऑल्सो राइट t minus t infinite is equals to e to the minus time by time constant. ये होता है time constant. Okay, so this is also given, so let me put the values. 350 minus 300 अपॉन इनिशियल टेम्परेचर कितना था 1000 माइनस 300 इज इक्वल्स टू ई टू द पावर, टाइम मुझे निकालना है, टाइम कांस्टेंट मुझे 16 दिया हुआ है. ओके, तो ये कितना हुआ 50 बाई 700 ln I can take minus t by 16 and time I can calculate here is 42.23 seconds. Okay, simple only lie, right? Okay, let's move on to the next question. Next questions, I think same question. Okay, because unsteady state questions are almost similar, same concept, same formula is to be applied. Okay, now again a steel ball of diameter is equals to 60 millimeter is initially in thermal equilibrium, initially है 1030 degree Celsius पे. It is suddenly removed from the furnace and cooled in ambient air at 30 degrees Celsius with convective heat transfer coefficient is equals to 20. Density is also given. Conductivity is also given. And specific heat is also given, 600 joule per kg Kelvin. The time required in seconds I need to find out. Seconds में हमें time निकालना है to cool the steel ball in air from 1030 to, यानी कि फाइनल टेम्परेचर कितना होना चाहिए 430 डिग्री सेल्सियस. 430 डिग्री सेल्सियस. सेम कॉन्सेप्ट, सेम फॉर्मूला, सेम इक्वेशन. ओके, क्या लिख सकता हूं मैं, t minus t infinite upon t initial minus t infinite e to the power ha upon rho vc by time. ये टाइम निकालना है मुझे. ओके, सो इनिशियल टेम्परेचर, फाइनल टेम्परेचर कितना है 430. यहाँ पे ln आ जाएगा, यहां से e हट जाएगा. ओके, माइनस h 20 बाई डेंसिटी कितना है 7800, स्पेसिफिक हीट है 600 and LC is equals to V by A is equals to D by 6. तो डायमीटर कितना है 60 into 10 to the power minus 3 by 6 into time. Very simple. I can calculate this ln 400 by 1000 is equals to 120 upon, I can calculate this, it's very easy, nothing is there. Okay, so it will come out to be this, I think minus t upon 234, something like this you will get, and then you can calculate your time is equals to 2144 seconds. Okay, so this is your answer. 2144, D is the answer. Okay, I hope it is clear. Okay, chalo, let's move on to the next question. Okay, a spherical steel ball of diameter 12 millimeter is initially at temperature 1000 Kelvin. It is slowly cooled in a surrounding कितना है 300 Kelvin. The heat transfer coefficient between the steel ball and the surrounding is 5 watt per meter square Kelvin. The thermal conductivity K is equals to 20 watt per meter Kelvin. The temperature difference between the center and the surface of the steel ball. The temperature difference between the center and the surface of the steel ball is क्या होगा? तो आपको ये बात ध्यान ध्यान रखनी है कि देर आर टू कंडीशंस. ओके, देर आर टू कंडीशंस. ओके, पहले तो हम बायोट नंबर निकाल के देखते हैं कि बायोट नंबर इज इक्वल्स टू एच एल सी बाई ए होता है. एल सी कितना होता है? वॉल्यूम पर यूनिट एरिया यानी कि डी बाई 6. एल सी इज इक्वल्स टू 12 into 10 to the power minus 3 by 6. Okay, so this is 0.002. Okay, now h कितना है 5 into 0.002 by k is 20. By k is 20, so ये आ गया 0.0005. Now we can see here that it is much less than 0.1. Okay, तो अगर ये बहुत कम है 0.1 से, so ये कंडीशन क्या होती है हमारे पास? Is less than 0.1, then internal conductive resistance is much less than external convective resistance. ये बात तो पता ही है हमें. अगर बायोट नंबर इज मच लेस देन 0.1, सो कंडक्टिव रेजिस्टेंस जो होता है वो बिल्कुल ही जीरो होता है. तो अगर इंटरनल कंडक्टिव रेजिस्टेंस बहुत कम है, इसका मतलब क्या है? Thermal conductivity is almost infinite, and therefore there is no temperature gradient, or I can say very small temperature gradient inside the body. तो टेम्परेचर ग्रेडियंट जो होता है, द होल बॉडी इज मेंटेन्ड एट अ कांस्टेंट टेम्परेचर. बॉडी के अंदर कोई टेम्परेचर डिफरेंस नहीं है. तो और वो क्यों है? क्योंकि कंडक्टिविटी इज इनफाइनाइट. ऐसा नहीं है कि सेंटर पे कोई और टेम्परेचर है, बाहर कोई और टेम्परेचर है. अगेन इट इज एन assumption. It really doesn't happen like this, but it is an assumption with certain, satisfaction. Okay, so it is small because conduction resistance is far large. No, it is not large. It is not large. So last two options we can see small because conduction resistance is far higher. No, small because conduction resistance is far less than convective resistance. Okay, so this is the right option. Okay, now let us see the next question. I hope that is visible to you, right? Okay, no, it is a fin question. It is a fin question. Okay. A fin, try to read out the question in 20 seconds and then we will start this. Okay. So, a fin has 5 millimeter dia. ये कितना है? 5 millimeter dia and the length, here x is equals to 0, here x is equals to L is equals to 100 millimeter. Okay. Thermal conductivity is also given. K is how much? K is equals to 400 watt per meter Kelvin. One end of the fin is maintained at 130 degrees Celsius. So this end, here base temperature is equals to 130 degrees Celsius and the rest of the fin is exposed to the surrounding with T infinite is equals to 30 degrees Celsius. Convective heat transfer is also given. H is equals to 40 watt per meter square Kelvin. Heat loss from the fin is okay. So unless it is not given, we always take finite with insulated tip. Okay. So let us assume fin with finite length and insulated tip. This is the case. Other So they could tell you that it is an infinitely long fin. So you know now what to use. Otherwise, they will mention it is uninsulated tip. So otherwise mentioned, unless otherwise mentioned, you will take this case. Fin with finite length with insulated tip. Okay. Now, how do you find out the heat transfer? Q of fin is equals to under root HPKA, under root HPKA T naught minus T infinite tan H MLC. Okay. So now you know everything. You know everything, right? Corrected लेंथ नहीं आएगा इसमें LC ही आएगा. Okay. Now H you know, P and A you know because R is given, D is given. Conductivity you know. M I need to find out. M क्या होता है सर? M होता है, यहाँ पे लिख लेते हैं. What is M? M is equals to under root HP by KA, right? HP by KA. सिंपल. सो अब कैलकुलेट कर लो इसे. क्या दिया हुआ है? एच दिया हुआ है हमें अंडर रूट 40. ओके. डायमीटर कितना दिया हुआ है? डायमीटर दिया हुआ है 5. सो पाई डी. के कितना दिया हुआ है? 400 इंटू पाई बाई 4 टी स्क्वायर. ओके. M is equals to under root. If you solve this, 40 into perimeter you will get. I am not solving this. I will directly write this. Perimeter you will get how much? Perimeter is 0.0157. Similarly, area you will get 1.95 into 10 to the power minus 5. This is the area that you will get if you substitute the diameter. Okay. So M is equals to 8.97 meter inverse. Okay. Now let me put the values. एच कितना है, एच हमारे पास 40, पेरीमीटर कितना है 0.0157, के कितना है 400, एरिया कितना है 1.95 इंटू 10⁻⁻⁵. ओके, टी नॉट is 130, T infinite is 30 into 10 हाइपरबोलिक m कितना है 8.97 into लेंथ कितनी है 0.1 मीटर. Okay, so if you can solve this, very simple, just one equation. Okay, so you will get how much 0.0699 तो ये आएगा 100 ये आएगा. ओके, एंड 10 हाइपरबोलिक 0.897 आपका ये आएगा. एंड द ऑप्शंस आर 0. You will get how much 4.99 watts, which is also equal to 5 watts. So B is the right answer. Clear? Now let's move on to the next question. Hope it is visible to you now. Okay, let us read it quickly. A small copper ball of 5 millimeter diameter कितना है, कॉपर बॉल है 5 मिलीमीटर डाया है आपके पास, ऑफ इनिशियली टी इनिशियल कितना है आपका इसमें सेम 500 Kelvin. Same thing we have discussed so many times. Okay, is dropped into a oil bath whose temperature is 300 Kelvin. ऑयल बाथ का मतलब क्या है, सराउंडिंग टेम्परेचर. थर्मल कंडक्टिविटी इज गिवन 400 watt per meter Kelvin. Density is given 9000 kg per meter cube. Specific heat is given, C is equals to 250 watt per meter square Kelvin. Look, sometimes I write Cp, sometimes I write C. It's same. For solid, it does not matter. Cp is equals to Cv is equals to C. It's all same for solids. For liquid and gases, in fact for liquid also it is same. For gases they are different. Okay, C ये है. And lumped analysis assumed to be valid. The rate of fall of temperature of the ball at the beginning of the the rate of fall of the temperature of the ball at the beginning of the cooling will be. Beginning of the cooling means हमें निकालना है dt, rate of change of temperature with respect to time at time is equals to 0. At the beginning at time is equals to 0. I need to find out. Okay, चलो, this is something that I need to find out. Now क्या इक्वेशन है हमारे पास, क्या बेसिक इक्वेशन है हमारे पास, हमारे पास इक्वेशन है t minus t infinite upon t initial minus t infinite e to the power ha rho vc by time, isn't it? अब क्या हो गया, टाइम टेम्परेचर इज इक्वल्स टू टी इनफाइनाइट प्लस टी आई माइनस टी इनफाइनाइट e to the power minus ha upon rho vc by time. अब मुझे इसे डिफरेंशिएट करना है विद रिस्पेक्ट टू टाइम. तो ये तो 0 हो जाएगा, ये ऐसे ही रहेगा और ये रहेगा e टू द पावर ha रो वी सी टाओ इनटू, इसको मुझे डिफरेंशिएट करना है तो यहां पे आ जाएगा माइनस एच ए अपॉन रो वी सी इंटू 1. राइट, नाउ मुझे कब कैलकुलेट करना है? एट टाइम इज इक्वल्स टू जीरो। तो अगर मैं टाइम जीरो पुट कर दूंगा तो मुझे मिलेगा टी इंटू ई वाली वैल्यू पूरी ये हो जाएगी 1। ओके, एंड आई विल गेट माइनस एच ए अपॉन रो वी सी। दिस इज व्हाट आई विल गेट। ओके, चलो टी इनफाइनाइट कितना है? 500 माइनस 300 इंटू माइनस एच कितना है? एच इज नॉट गिवन। थर्मल कंडक्टिविटी इज गिवन। 250 is given. Okay, H I have not written. H is equals to 250 watt per meter square Kelvin is given in question. Okay, so minus 250 upon density कितनी है? 9000 into 250. See specific heat कितनी है? 385. Okay, so this was the mistake. This is 385, right? Okay, so this is my bad. 385 and volume per unit area is 5 into 10 to the power 6 into 6. Why? By LC is equals to volume per unit area is equals to D by 6. तो मैंने D by 6 लिख दिया. Okay, so you can solve this. You can solve this. There is nothing much in this. Okay, very simple. So you will get how much? Minus 17.31 seconds. Kelvin per second. Kelvin per second. Sorry. Temperature यानी कि Kelvin per second. They're asking only the magnitude. So dt by dt only magnitude is equals to 17.31 Kelvin second. So C is the right answer. Clear? Okay. Chalo, let us move on to the next question. Something similar again. Something similar question. Spherical thermocouple junction of diameter dia दिया है कितना? 0.706 millimeter. The convective heat transfer coefficient is 400 watt per meter square Kelvin. उसके बाद थर्मल कंडक्टिविटी कितनी दी है? 20 वॉट पर मीटर केल्विन. स्पेसिफिक हीट दी है जूल पर केजी केल्विन. डेंसिटी कितनी दी है? 8500 केजी पर मीटर क्यूब. एंड थर्मोकपल अगर इनिशियली 30 डिग्री सेल्सियस था, इनिशियली एट 30 डिग्री सेल्सियस प्लेस्ड इन टी इनिशियल कितना है? 30 डिग्री सेल्सियस. एंड टी इनफाइनाइट कितना है? 300 डिग्री सेल्सियस. और ये है 298 डिग्री सेल्सियस. टाइम टेकन आई नीड टू फाइंड आउट. सेम क्वेश्चन, सेम कॉन्सेप्ट, सेम डेरिवेशन, सेम इक्वेशन, नथिंग न्यू. ओके, क्या है इक्वेशन? टी माइनस टी इनफाइनाइट, टी इनिशियल माइनस टी इनफाइनाइट माइनस एच ए अपॉन रो वी सी. ओके, चलो ये कितना है? ओके, तीन फाइनाइट है 300, राइट। एलन अगर आप यहां ले लोगे तो यहां पे क्या बचेगा आपके पास, माइनस एच 400, डेंसिटी इज 8500, सी इज 400, वॉल्यूम वॉल्यूम कितना है, वॉल्यूम पर यूनिट एरिया, अगेन एलसी इज इक्वल्स टू वॉल्यूम पर यूनिट एरिया, डी कितना है 0.706 सिंपल, इनटू टाइम, टाइम निकालना है मुझे, तो आप इसे सिंपल कैलकुलेट कर सकते हैं। एल एन टू तो ये होगा -2, सॉरी, और ये -270 ये होगा। ओके, तो इसे भी आप कैलकुलेट कर लेना, वेरी सिंपल। तो यहां से आपको टाइम मिल जाएगा 4.9 seconds. Everything else is known to me. So he is the right answer. Okay. Now let us move on to the next question. Okay. चलो, let's move on to the next question. क्या कह रहा है क्वेश्चन, टू रॉड्स, दो रॉड हैं, वन ऑफ लेंथ एल एंड द अदर ऑफ लेंथ 2l. ओके, तो एक रॉड ये है, ओके, सो दिस इज बेसिकली, so this is L, this is 2L. Okay, they are made of same material, they are made of same material. So इसे अगर हम A कह दें, इसे अगर हम B कह दें, तो Ka conductivity, thermal conductivity is same, and diameter is also same. Phi of A is equals to phi of B. The two ends of the longer rod के both the ends are maintained at 100 degree Celsius. ओके, दोनों मेंटेन एट 100 डिग्री सेल्सियस। एक वन एंड ऑफ द शॉर्टर रॉड इज मेंटेन्ड एट 100 डिग्री सेल्सियस एंड द अदर एंड, दिस वन इज इंसुलेटेड। ओके, दिस वन इज इंसुलेटेड। द टेम्परेचर एट द इंसुलेटेड एंड ऑफ द शॉर्टर रॉड, यहां पे कितना है टेम्परेचर, T इज इक्वल्स टू 55 डिग्री सेल्सियस। टेम्परेचर एट द मिड पॉइंट, यहां पे हमें बताना है एट x इज इक्वल्स टू L, यहां पे टेम्परेचर कितना होगा, यहां पे टेम्परेचर TB TA बताना है हमें कितना होगा एट x इज इक्वल्स टू L, एट x इज इक्वल्स टू L, ये हमें बताना है। ठीक है, चलो, नाउ आई यू सी दैट बोथ द एंड्स, let us talk about rod B. For rod B, you see both the ends are maintained at same temperature. दोनों एंड हमने एक ही टेम्परेचर मेंटेन किए हुए हैं, तो इसका मतलब क्या है, एक हमें मिनिमम मिल रहा होगा, एक हमें मिनिमम टेम्परेचर मिल रहा होगा एट द सेंटर ऑफ द मिड प्लेन, एट द मिड प्लेन ऑफ दिस रॉड। ओके, तो एट x इज इक्वल्स टू L मीन्स हाफ लेंथ पे, एट दिस लेंथ वी गेट टेम्परेचर मिनिमा और टेम्परेचर मिनिमम वैल्यू। तो कैन आई से एट x is equals to L, T is equals to dt by dx is equals to 0, क्योंकि मिनिमा है या मैक्सिमा है, dt is equals to dx, तो 0 रहेगा ही। ओके, चलो अब लेट अस टॉक अबाउट फॉर रॉड ए। अगर हम रॉड ए की बात कर रहे हैं तो यहां पे क्या कंडीशन है हमारी, एट x is equals to L, the rod is insulated, इंसुलेटेड है यानी कि कुछ भी हीट पास नहीं हो रही है, तो यहाँ पे आपको एक मैक्सिमा मिलेगा, यहाँ पे एक मैक्सिमा मिलेगा। तो यहाँ पे ऑल्सो डी टी बाई डी एक्स इज इक्वल्स टू 0, यानी कि आप इस कंडीशन और अगर इस कंडीशन को कंसिडर करें तो वी आर, यू सी, यू कैन इमेजिन दिस रॉड इनटू टू पार्ट्स लाइक दिस इज वन पार्ट एंड द अदर वन इज द डिफरेंट पार्ट। नाउ अगर हम इस पार्ट को देखें, ग्रीन पार्ट को, तो व्हाट इज हैपनिंग, वन एंड इज एट 100 डिग्री सेल्सियस एंड द अदर एंड हैज अ मिनिमा। ऐसे आप रॉड ए को देखो, एक एंड है 100 डिग्री सेल्सियस पे, द अदर एंड हैज अ मैक्सिमा। ओके, सो मैक्सिमा और मिनिमा वट एवर इट इज, राइट, बट डी टी बाई डी एक्स इज इक्वल्स टू 0 होगा, डी टी बाई डी एक्स विल बी इक्वल टू 0। तो बाई कंपेयरिंग हम क्या कर सकते हैं, हम मान सकते हैं कि हमारी रॉड बी जो है ये दो हिस्सों में बटी हुई है, जिसमें का एक हिस्सा जो है वेयर वन साइड इज 100 डिग्री सेल्सियस द अदर साइड इज insulated. So by comparing A and B, I can write that for this condition, for rod B, at x is equals to L, T is equals to 55 degree Celsius. 55 degree Celsius. Okay. So it is C. I hope it is clear. Okay. Let's move on to the next question. A hot steel spherical plate ball is suddenly dipped into the low temperature oil bath. Which of the following dimensionless parameters are required to determine the instantaneous center temperature of the ball using a Hassler chart? Hassler chart. So I hope you are all aware of Hassler chart. कैसा होता है Hassler chart? This looks like as a Hassler chart. क्या होता है कि यहाँ पे होता है आपका थीटा बाई थीटा नॉट, यहाँ पे होता है आपका फोरियर नंबर, और यहाँ पे आपकी बायोट नंबर, बायोट लाइंस जो है they are at particular Biot number. For example, this is Biot number is less than 1. Here Biot number is equals to 1. Here Biot number is greater than. So basically Hassler chart, अगर आपको फोरियर नंबर पता है और बायोट नंबर पता है तो what you can do? For example, you know by fourier number, you mark it here, you know Biot number as well. You go here, mark it here at this line and check थीटा बाई थीटा नॉट, एंड यहां से आपको मिल जाएगा टेम्परेचर, इंस्टेंटेनियस सेंटर टेम्परेचर, वट एवर टेम्परेचर यू वॉन्ट टू फाइंड, टी माइनस टी इनफाइनाइट on T naught minus T infinite, whatever you want to find, you can find it from here. Theta naught by theta 1 होता है ये, ठीक है, थीटा नॉट बाई थीटा 1। दिस इज थीटा नॉट बाई थीटा 1। सो यहां पे क्या आएगा, थीटा टी नॉट बाई टी आई। ओके, so once you know Fourier number and Biot number, you will be able to determine the temperature at any point t infinite. Clear? So by using Hester chart, what are the two numbers that we need? We need Biot and Fourier number. Biot and Fourier number. You can also determine it by using our equation. What? Theta by theta naught is equals to e to the power minus h a upon rho vc by time. Okay, what can I do? E is equals to minus h upon rho c lc by lc is equals to वॉल्यूम पर यूनिट एरिया इज इक्वल्स टू डी बाई 6। अगर वो स्फेरिकल बॉल है तो पर वी बाई ये तो होता ही है, इनटू टाइम। ओके, नाउ कैन आई राइट h into 1 upon rho c lc into time। okay, now let me divide and multiply whole equation by k। okay, now let me also divide and multiply by a lc। तो यहाँ पे lc ऐसा आ गया, यहाँ पे lc स्क्वायर हो गया, lc स्क्वायर हो गया। ओके, अब एक बात और बताओ, अल्फा क्या होता है थर्मल डिफ्यूजिविटी, k अपॉन रो सी। तो क्या मैं इसे लिख दूं माइनस एच एल सी बाई के इंटू एल्फा टाओ टाइम इंटू एल सी स्क्वायर। यस, एंड इट इज थीटा बाई थीटा नॉट। तो ये क्या होता है आपका, ये होता है बायोट नंबर, और ये क्या होता है, ये होता है आपका फोरियर नंबर। ओके, दिस इज योर फोरियर नंबर। So basically your theta by theta naught is a function of Biot number and Fourier number, you can say that. Clear? So what is the right answer? Biot on Fourier number. Okay. Yes, I know, but it's okay. I mean, it is a recorded session, so people can watch it later. Okay. Chalo. Let us move on to the next question. Okay. An infinitely long fin attached to a isothermal hot surface. क्या कह रहा है कि आपकी जो फिन है वो इनफाइनाइटली लॉन्ग है। ओके, इट इज इनफाइनाइटली लॉन्ग। सो लेंथ इज x इज लेंथ इज इक्वल्स टू इनफाइनाइट, x इज इक्वल्स टू l इज इक्वल्स टू। हम Q1 हम ट्रांसफर कर रहे हैं, transfer heat at a steady rate to the ambient air। okay, so not this, the heat that is transferred Q.1 to the ambient। if the thermal conductivity, अगर आप थर्मल कंडक्टिविटी इंक्रीज कर रहे हो, इस डबल कर रहे हो, यानी कि इनिशियली आपका है K1 इज इक्वल्स टू K एंड फाइनल आप कर रहे हो 2K, डबल कर रहे हो। the rate of steady state heat conduction from the fin becomes, कितना बढ़ जाएगा, कितना बढ़ जाएगा. So for fins with infinitely long लेंथ अगर होती है तो Q.1 जो होगा मेरा वो क्या होगा, अंडर रूट HPKA T0 minus T infinite, right? What? अब मैं क्या कह रहा हूं कि इसकी कंडक्टिविटी बढ़ा दो, तो कंडक्टिविटी बढ़ा के क्या होगा, डबल कर दो. तो HP2K एरिया T0 minus T infinite. What? तो अगर मैं Q2 डिवाइड बाई Q.1 कर दूं तो इट विल बी इक्वल टू दिस. तो बेसिकली अगर आप कंडक्टिविटी डबल कर रहे हो, इफ यू आर डबलिंग द कंडक्टिविटी, योर हीट ट्रांसफर इज इंक्रीज्ड बाय रूट 2, by square root of 2. Okay, so it is square root of 2, right? Okay, let us move on to the next question. Let us move on to the next question, and this question is telling me the heat loss from a fin. So Q dot fin जो है आपका वो है 6 watts. इफेक्टिवनेस कितनी है 3, एफिशिएंसी कितनी है 0.75. The heat loss from the fin keeping the entire fin surface at the base temperature. क्या होता है ये कि जब भी आप ये मान लो कि जैसे आपके पास अगर ये आपका टी बेस होता है ऐसा, ठीक है. ये आपका टी बी है बेस. ओके, हम अगर ये मान लें कि हमारी सारी फिन जो है वो टीबी पे ही है, हमारा जो पूरा जो टेम्परेचर है इस फिन का, इट इज एट टीबी. ओके, सो अगर ये यहां से क्या होगा Q डॉट एक्चुअल और यहां से क्या होगा Q डॉट मैक्सिमम. If we consider the whole fin is at the base temperature, we will get the maximum heat transfer that could happen from the fin. Fin से कितना maximum heat transfer हो सकता है वो हमें जब मिलेगा if we consider because TB is the highest temperature. TB is the highest temperature. Okay, so basically they are asking calculate Q dot max. How do I calculate? Efficiency क्या होती है fin की? Q dot actual upon Q dot max. ओके, तो ये है 0.75 इज इक्वल्स टू 6 अपॉन Q डॉट मैक्स. तो Q डॉट मैक्स यू कैन कैलकुलेट 6 अपॉन 0.75 and I think you can get 8 watts. Yes, 8 watt. Okay, so this is your maximum temperature when you are assuming that the entire fin is at same temperature. Okay, base temperature. Now let us see the next question. Biot number signifies the ratio of this. You must know this. You must know Biot number क्या कहता है. Biot number tells you is the ratio of internal conductive resistance upon external convective resistance. Okay, so what is the right answer? Conductive resistance in the solid to convective resistance in the fluid. Yes, B is the right answer. Okay, let us move on to the next question. Again, good question. Okay, so what is this telling me? Ki which one is the configuration which will give you which will give you the maximum effectiveness? Highest pin effectiveness. तो क्या होता है pin effectiveness? कोई बताएगा? Effectiveness is equals to Q dot with fin. भाई फिन को लगाने से कितना हीट ट्रांसफर एनहेंस हो गया है, दैट इज कॉल्ड एज इफेक्टिवनेस. इट इज कॉल्ड एज इफेक्टिवनेस. तो अगर हम इनफाइनाइटली लॉन्ग, वन सेकेंड, इफ वी कंसिडर इनफाइनाइटली लॉन्ग फिन, तो हम इफेक्टिवनेस लिख सकते हैं क्या? अंडर रूट एच पी के ए टी नॉट माइनस टी इंफिनिटी एच ए टी नॉट माइनस टी इंफिनिटी. So you can cancel it. You will get under root kp by ha. तो यहां से हम क्या कंक्लूड कर सकते हैं? We can conclude that effectiveness is directly proportional to thermal conductivity, inversely proportional to heat transfer coefficient and directly proportional to perimeter by area. तो ये वैल्यू हाई होनी चाहिए. पेरीमीटर शुड बी हाई फॉर अ गिवन एरिया. कैसे मिलेगा हमें? बाई thin and closely spaced, high perimeter per unit area, high perimeter in a given area. Okay, so thin closely shaped fin, first is the answer. Next question. ये तो we have seen numerous number of times. The value of Biot number is very small when, so many times in the from the very beginning we are looking at this question कि अगर Biot number is less than 0.1, that means internal conductive resistance is much less than external convective resistance. ओके, तो ये कौन सा है? इंटरनल कंडक्टिव रेजिस्टेंस. ये क्या है? कन्वेक्टिव. तो कंडक्टिव रेजिस्टेंस जो होता है बहुत कम होता है कंपेयर टू कन्वेक्टिव रेजिस्टेंस. सिमिलरली यू कैन से, और क्या कंडीशन होती है कि थर्मल कंडक्टिविटी ऑफ द सॉलिड कंसिडर्ड टू बी वेरी हाई, इनफाइनाइट, ऑलमोस्ट इनफाइनाइट, एंड टेम्परेचर इज कांस्टेंट इनसाइड द बॉडी, इनसाइड सॉलिड बॉडी. ओके, सो कंडक्टिव रेजिस्टेंस बहुत कम होता है, तो कंडक्टिव रेजिस्टेंस ऑफ द सॉलिड इज नेग्लिजिबल, ऑफ सॉलिड इज नेग्लिजिबल. तो सी इज द correct answer. Let us move on to the next question. Lumped heat transfer analysis of a solid object suddenly exposed to the fluid medium at a different temperature is valid when so many times we have discussed this already. If Biot number is less than 0.1, then only lumped heat transfer analysis. So many names are there of this. Lumped heat transfer analysis. Some people say lumped heat capacity analysis, lumped capacitance analysis, lumped heat transfer analysis, unsteady state analysis, whatever you want to call it. So lumped heat transfer analysis is valid. Okay. Biot number is less than 0.1. Okay. What is the next question? Biot number signifies, just now we have seen, Biot number signifies the ratio of internal conductive resistance upon external convective resistance. Conductive resistance by convective resistance. तो ठीक है, the ratio of heat conducted, okay, in terms of heat if they ask you, तो इसका रिवर्स हो जाएगा क्या? Heat convected upon heat conducted. अगर कंडक्टिव रेजिस्टेंस ज्यादा है तो हीट ट्रांसफर, अगर वो डायरेक्टली प्रोपोर्शनल टू कंडक्टिव रेजिस्टेंस है तो इनवर्सली प्रोपोर्शनल टू हीट कंडक्शन होगा, ठीक है। अगर वो रेजिस्टेंस के डायरेक्टली प्रोपोर्शनल है तो हीट ट्रांसफर के इनवर्सली प्रोपोर्शनल होगा। तो रेशियो ऑफ हीट कन्वेक्टिव टू हीट कंडक्टेड, बी इज द heat convected to the ratio of external, okay, ratio of resistance में भी दिया हुआ है, okay, so ratio of internal conductive resistance to external convective resistance, so D is the right answer, okay, next, yeah, so this one is correct, okay, they have, because they have already, although if you choose B then also it will be correct, but what is happening here is they have already fed the result at D. So anyway, resistance they have given in the form of resistance, it's all right, no problem, okay. Last question, 21 question. A heat transfer process between a body and its ambient is governed by internal conductive resistance and external convective resistance. The body can be considered to be a lumped heat capacity system if, simple यार, Biot number is less than 0.1. Biot number क्या होता है? Internal conductive resistance upon external convective resistance. अगर ये less than 0.1 है, that means internal conductive resistance is less than 0.1 times of external conductive resistance. Okay, so basically internal conductive resistance is negligible. Okay, is negligible. So D is the right answer. Okay, so I hope it is clear. I hope it is clear. Okay, so this was the last question for fins. We'll meet day after tomorrow and we'll start questions of convection. Okay, we'll take 2 sessions of convection, convection 1, convection 2, and we will finish all the questions for convection. Okay, so I hope you are having good practice of your questions. Keep practicing. Goodbye. Bye bye.